Welcome to Trinath chemistry classes. In this video, I am going to discuss about intermediate second year chemistry topic, general principles of metallurgy. This is my fourth video in this general principles of metallurgy. In my third video, I have discussed about electrolytic refining, what is refining, why we require refining, and what are the various methods available for refining of metals. We have distillation, liquefaction, pooling, zone refining, electrolytic refining, and vapor phase refining. In my third video, I have discussed about electrolytic refining. In this video, I am going to discuss about vapor phase refining of metals. Vapor phase refining of metals. There are 2 points mainly in this. These are important for intermediate public examination point of view. Please like the video, share and subscribe the channel. So what is vapor phase refining? What is the principle involved in this vapor phase refining? So in this vapor phase refining, first metal is converted to volatile compound. Metal is converted to volatile compound. So in this method, initially metal is converted to its volatile compound. Converted to its volatile compound, and in second step, it is collected somewhere else. So then whatever the collected one is again decomposed to get the required metal. Initially, the metal is converted to its volatile compound, and this volatile compound is collected. This volatile compound is collected somewhere else, and this collected compound is again decomposed to the metal. So whatever impurities are present or remains in this metal only, they will not convert into volatile, as the impurities will not convert into their volatile compounds. Only metal is converted into its volatile compound. So vapor phase refining, the basic idea of this vapor phase refining is metal only forms volatile compound but not impurities. Then only we'll use this method. Metal only forms volatile compounds. So hence what happens? Metal was initially converted to volatile compound. When it is converted to volatile compound, impurities remains in the metal itself. Impurities remains in the metal only. Right? Metal only converts to volatile compound. This volatile compound, whatever vapor converted, volatile compound of the metal is collected and again decomposed to get the required metal. So the vapor phase refining example is Mond's process. For 2 marks, this question may be important, and in objective point of view also, this is important. So what is Mond's process? So this is the vapor phase refining method which is used to refine the nickel metal. So in this, initially nickel is heated in a stream of carbon monoxide, and it forms a volatile nickel tetracarbonyl nickel. It forms volatile tetracarbonyl nickel. Then when this tetracarbonyl nickel is subjected to high temperature, it decomposes and get back our nickel and carbon monoxide. This is Mond's process. So Mond's process is used for the refining of the nickel. So this is one of the best example for the vapor phase refining. In this, nickel metal is heated with carbon monoxide to form a volatile tetracarbonyl nickel, which is a volatile compound which will be collected and which on heated at high temperature to get back our nickel. So impurities remain in that metal itself, impure metal itself. The impurities forms as a mud. So this is regarding Mond's process. And second example is Van Arkel method. Van Arkel method. So what is this Van Arkel method? Van Arkel method. This method is used to refine the zirconium or zirconium or thorium. Sorry, titanium. Zirconium or titanium. So this method uses this method is very useful for the removing the all the oxygen and nitrogen present in the form of impurity in the certain metals like zirconium, titanium. This Van Arkel method, this Van Arkel method is mainly is very useful technique for removing all the oxygen and nitrogen present in the form of impurity in metals such as zirconium or titanium. Zirconium or titanium. So what happens is in this Van Arkel method, the metal, crude metal is heated in a evacuated vessel. Crude metal is heated in a vessel. Heated in a vessel, evacuated vessel. Heated in a evacuated vessel with iodine. With iodine. Then what happens is with the iodine, what happens is the whatever metal is there that is converted into volatile metal iodide. Volatile metal iodide. Volatile metal iodide. So these metal iodides are further decomposed on tungsten, further decomposed on tungsten filament electrically heated in about 1800 Kelvin. 1800 Kelvin, the pure metal is obtained. The pure metal is obtained. So in this Van Arkel method, the crude metal is heated in a evacuated vessel with iodine. Heated with iodine in a evacuated vessel, it forms a volatile metal iodides. These metal iodides are further heated electrically. Further heated electrically at 1800 Kelvin. 1800 Kelvin to get back our metal. To get back our metal. So Van Arkel method is mainly useful for the purification of zirconium and titanium. In this method, crude metal is treated with iodine in a evacuated vessel at high temperatures to form metal iodides. These metal iodides further decomposed electrically to get back our metals. For example, if you take zirconium when treated with iodine, it forms zirconium iodide. This zirconium iodide further decomposed to get back our zirconium. This is regarding Van Arkel method. So this is about the Mond's process and Van Arkel method. So these two methods are important for not only for IPE point of view, in any kind of objective exams. This technique will be used. Mond's process is useful for nickel, and this Van Arkel method is useful if oxygen or nitrogen is present as impurity in metals such as zirconium, titanium. So in Van Arkel method, the metal is treated with, the crude metal is treated with iodine to form corresponding iodides. These iodides further decomposed electrically to get a metal. Thank you for watching Trinath chemistry classes. Please like, subscribe, share the video. Subscribe the channel.